Hello and welcome to helpyourmath.com. In this video, we are going to take a look at the 8 guidelines to kind of help us determine whether a statistical study contains bias, is valid, should we believe it, or not. Almost every statistical study will have some form of bias. It's pretty much impossible to not include any sort of bias into a study, which doesn't mean that every single study is garbage, but it does mean that we should be very discerning when we see something. So if you see a statistical study that says 85% of people, whatever, these are the 8 things to consider when we read these studies. Okay, so number 1, get a big picture view of the study. You should understand the goal of the study, the population that was under study, and whether the study was observational or an experiment. So observational, that just means you're not interfering in any way. And experiment means you have a control group and you have an experimental group, and then you're comparing the results. Okay, so just to look at an example, imagine a news report that says, researchers gave 100 participants their astrological horoscopes and asked whether the horoscopes appeared to be accurate. They found 85% of the participants answered yes, that their horoscope was in fact accurate. The researchers concluded that the horoscopes are valid most of the time. So based on this guideline of getting a big picture view of the study, what are the potential problems? Would this study be valid? Should we believe this, that horoscopes actually are pretty accurate? Okay, so number 1, the goal of the study. Who are these researchers? What's their, are they behind the Astrological Society of America? Because if that's the case, they might have some sort of bias about who exactly they're asking. And same with the population under study. So if it's my made up Astrological Society of America, maybe they were at a tarot card reading convention, where most people probably would believe that their horoscopes are in fact accurate. Was this observational or an experiment? This seems like it would be observational. People read their horoscope. They were not, given any information otherwise, but that also could be problematic because, we don't know what these horoscopes say. They could be very broad, like today you will have breakfast. Probably people are going to agree with that, except for the 15% who didn't have breakfast. So really this should have been an experiment where there were real horoscopes and fake horoscopes, and see if there's any difference between the ones who were given their real horoscope. Did they agree with the real one more often than the fake one, right? So there's all these different ways that this study could have been a little bit more reliable. So again, how are the participants chosen? Who are the researchers? And basically, the results are meaningless. We don't really know what these horoscopes said. Where were they pulled from? No, I'm not buying this study. Okay, number 2, consider the source. So I kind of mentioned, I made up this society, the Astrological Society. They might have a bias in the outcome, right? They're gonna specifically target a population or, kind of throw some data in the trash that doesn't meet what they're trying to prove. So we want to look for any potential sources of bias on the part of the researchers. By 1963, enough research on the health dangers of smoking had accumulated that the Surgeon General of the United States publicly announced that smoking is bad for health. Research done since that time has built further support for this claim. However, while the vast majority of studies show that smoking is unhealthy, a few studies have found no dangers from smoking and perhaps even health benefits. These studies generally were carried out by the Tobacco Research Institute, funded by the tobacco companies. Analyze the Tobacco Research Institute studies according to this guideline. Of course, they're going to find some sort of health benefit, and you can use these anecdotal cases. For example, growing up, I did gymnastics with somebody, we'll call her Jillian, and Jillian said, everyone in my family who smokes doesn't have lung cancer, and everyone who everyone who doesn't smoke in my family gets lung cancer, and everyone in my family who smokes doesn't get lung cancer. Therefore, I should take up smoking to protect myself from getting lung cancer. I'm like, I don't know about that, Jillian. Maybe this Tobacco Research Institute focused on her family, where it seems like somehow it was saving the smokers from getting lung cancer. But we know that that's not necessarily true. I don't know that they've shown that smoking does lead to lung cancer. It might be correlation versus causation. I don't know that off the top of my head, but it is something to consider. So the fact that the greater majority of studies done do in fact show smoking is bad for your health. There are no health benefits. I think, being funded by the tobacco companies, they're looking for positives. They're trying to make money, right? This is how they're getting all their money. It's by, these random studies, the one-offs that show it's actually healthy. So to conclude, I would also say this, I would probably be very skeptical of that small bucket of research that says, no, totally valid. Number 3, look for bias in the sample. Decide whether the sampling method was likely to produce a representative sample. And I will say here and now, it is incredibly difficult to get a representative sample. There are all sorts of sampling techniques that we've talked about, and we can try to do the best we can. It is incredibly difficult. So again, that's not to say every study is bad, but we should just keep in mind that it's virtually impossible to get a representative sample. 2 types of bias could occur in choosing a sample. The selection bias occurs when a researcher selects their sample in a way that tends to make it underrepresentative of the population. For example, a pre-election poll that surveys only registered Republicans has selection bias because it is unlikely to reflect the opinions of all voters. There's also participation bias. This occurs whenever people choose whether to participate or not. For example, if participation in a survey is voluntary, people who feel strongly about the survey issue are more likely to participate, so their opinions may not represent the larger population that is less emotionally attached to the issue. And we see participation bias everywhere, right? If you go to Yelp or any product review, really it's very skewed. You're going to have all, excellent reviews and all terrible reviews and very few in the middle, because the people who had a bad experience want to make sure their experience is told and try to warn people, don't buy this product, don't go to that restaurant. And the people who really love it also are going to, because they're emotionally invested in this. You would also see participation bias in Rate My Professor, right? You're going to go in if you love the professor or if you really, really didn't like them. So most professors probably have very few 3-star reviews, or 3 stars? I don't know. I don't look at it. Because it's the people who are emotionally charged who go and participate. All right, so we're looking for selection bias and participation bias. Which type of bias may occur in the following studies? An exit poll designed to predict the winner of a local election uses interviews with everyone who votes between 7 and 7:30 a.m. Well, that would be a selection bias. Who's going to be voting at 7 to 7:30? Especially if that's when the polls open, it's those people who are really excited to get out there and vote. People who don't have responsibilities at home, they don't have young children to throw in the car. Don't throw your kids in the car. To get their kids in the car to walk. Very specific people are voting that early in the morning. About the NRA, the National Rifle Association members are asked if they think carry and conceal should be legal nationally. Now, if you're asking people who are affiliated with the NRA, you're obviously going to have a participation bias. That would be a very skewed opinion, probably, than what the overall population of the US would feel about this particular issue. Guideline number 4. Look for problems in defining or measuring the variables of interest. Ambiguity in the variable can make it difficult to interpret reported results. Statistical studies attempt to measure something, and we call the things being measured the variables of interest in the study. The term variable refers to an item or quantity that can vary or take on different values. The variables of interest are the items or quantities that the study seeks to measure. Okay, so a Roper poll reported in USA Today involved a survey of the wealthiest 1% of Americans. The survey found that these people would pay an average of $487,000 for true love, $407,000 for great intellect, $285,000 for talent, and $259,000 for eternal youth. What do we think about this? Well, what does any of this mean? I mean, true love, I think we all can agree what that might be, but great intellect? Talent? What talent? What kind of talent? Just overall a talented person? Eternal youth? I mean, you can do that. You can get all the Botox you want, right? I mean, so what do these things even mean? This study makes no sense whatsoever. There's nothing meaningful we're getting from this based on this very ambiguous amount of money, and it doesn't make any sense. All right, let's look at number 5 now. Beware of confounding variables. If the study neglected potential confounding variables, its results may not be valid. Variables that are not intended to be part of the study can sometimes make it difficult to interpret results properly. These variables are often called confounding variables because they confound or confuse a study's results. Let's talk about radon. Radon is a radioactive gas produced by natural processes, the decay of uranium, in the ground. The gas can leach into buildings through the foundation and can accumulate in relatively high concentrations if doors and windows are closed. Imagine a study that seeks to determine whether radon gas causes lung cancer by comparing the lung cancer rate in Colorado, where radon gas is fairly common, with the lung cancer rate in Hong Kong, where radon is less common. Suppose the study finds that the lung cancer rates are nearly the same. Is it fair to conclude that radon is not a significant cause of lung cancer? So what do you think? What's going on here? Well, first of all, it seems very bizarre that they would be comparing the state of Colorado to Hong Kong, which is all the way across the world. Second of all, what could be a confounding variable? Well, one thing you may or may not know is that Colorado is one of the healthiest states in the United States, with a very low smoking rate, very few smokers in Colorado, versus Hong Kong, where the smoking rate is quite high. So, going back to that lung cancer question, is the lung cancer really from radon? Or could it be that there's more smokers in Hong Kong who develop lung cancer as a byproduct or just happen to get it because, for whatever reason? So I would say we can't say that it's not a problem just because of this one study. We need to consider other things that could be contributing to lung cancer. So I said other factors need to be consistent. If we were going to compare Hong Kong, which has a high smoke rate, we would just need to find another state that has a high smoking rate, or vice versa. We could use Colorado. Then let's find somewhere else that has less radon gas, but the smoking rate is pretty consistent. And this brings us to number 6. Consider the setting and wording in surveys. So this is a really big one. This can very largely, everyone is susceptible to falling for the way a question is phrased. Look for anything that might tend to produce inaccurate or dishonest responses. Dishonest responses are particularly likely when the survey concerns sensitive subjects, such as personal habits or income. Do you cheat on your taxes? Is unlikely to elicit an honest response from those who cheat. Because who's really gonna be like, yeah, I do. I cheat on my taxes, right? You're gonna feel put on the spot. You're gonna feel, why, who's asking? You might get paranoid. Sometimes the order of the words in a question can affect the outcome. A poll conducted in Germany asked, would you say that traffic contributes more or less to air pollution than industry? They also asked a separate set of people, would you say that industry contributes more or less to air pollution than traffic? So notice it's asking the same question, it's just switching the order. We have the traffic first, industry second, industry first, traffic second. So which one is going to cause more air pollution? You might think these are the exact same question, right? What does order matter? But the people who were asked the top question, 45% said traffic contributes more than industry, while 32% said industry contributes more than traffic. Of the people who were asked the bottom question, 24% said traffic contributes more than industry, while 57% said industry contributes more than traffic. So again, that was in the first one, 45% traffic versus 24% traffic. And 32% industry. By the first question, 57% who were asked the second question said industry. So just that the wording that we hear can affect how we interpret the question. Another example, the Republican National Committee commissioned a poll to find out whether Americans supported their proposed tax cuts. Asked, do you favor a tax cut? A majority answered yes. Should we conclude that Americans supported the proposal? I mean, that's a very vague question. Of course, we all want to pay less in taxes. You'd be crazy to say, no, you know what? I don't think I'm paying enough. But what exactly is getting cut, right? if there's going to be a tax cut, something's losing funding, you better be asking those questions. What exactly, where is this coming from? And actually, the majority of people did not favor the tax cuts because a lot of people were worried about the national deficit. And if you cut taxes, how are we going to get that deficit down to something more reasonable? So be very careful about the way the question is being asked. Okay, 2 to go. Number 7, the 7 of 8. Check that results are presented fairly. Check whether the study really supports the conclusions that are presented in the media. And then I would also say, if you pick up a newspaper, sometimes you see a statistic and it's just flat out wrong. They give you the raw data and the math is just wrong. So you have to be very careful about that as well. Okay, so check that the results are presented fairly. Even when a statistical study is done well, it may be misrepresented in graphs or concluding statements. Researchers or reporters of the data may misinterpret a survey or jump to a false conclusion to make a story seem more sensational. No, reporters wouldn't make a story seem sensational. Oh, no, wait, they absolutely would. So we need to be very careful about that. Let's look at these 2 graphs. Okay, they're beautiful. Yeah, that first one looks like a flat line. The second one, oh my gosh, it's like a U, and then it peaks, and then oh man, and then in 2009, look at that. Something bad is going on here. Oh wait, but then if we look at the headlines, average household income in 2009 dollars, these graphs are exactly the same. I'm going to zoom in so we can even see. But here on the y-axis, we start out at 0, we go in increments of tens of thousands of dollars. So we can conclude from this graph that the average household income ranged between, it looks like 52,000 and then it dropped kind of 50,000. Here, we miss a bunch. So there the the y-axis was consistent, but here the y-axis starts at 48,000. So we're seeing, it's like zooming in on this graph to see just how much it drops. And it looks like it's this huge drop. What year was that? 2002. Oh my goodness, what happened? And it gets lower, 2004. Then things start to look up and then it's like, oh my gosh, it's all going down. It's just going straight down into the garbage. But not really, right? It only went from 52,400-ish to just under 50,000. That's not that much. I mean, it's not great. We want to see it go up, but it's not a huge decrease that they might have you believe. So we have to check the axes. We have to be very careful about what is really being shown, even if we're given a graph that's fairly reliable. In another example, the school board in Boulder, Colorado created a stir when it announced that 28% of Boulder school children were reading, quote, below grade level, and concluded that methods of teaching reading needed to be changed. The announcement was based on reading tests on which 28% of Boulder school children scored below the national average for their grade. Do these data support the board's conclusion? Well, let's see. So if 28% are reading below grade level, that means 72% are at or above grade level, which is pretty good, right? 72% are at or above grade level. That's fantastic. I would also say, how far below grade level? Are they not reading at all? Are they like just barely below it? Also, it says that they're basing this off the national average. So, nationally, half the people are going to be below grade level. That's the way an average works. Half are going to be below, half are going to be above. So I don't think anything substantial needs to happen. I think Boulder is doing a fantastic job. And I reinforce that point here in my red. And lastly, we made it to the end. Number 8, stand back and consider the conclusions. So this is, with any study or hypothesis in science class, the last thing is always go back, reevaluate, take a step back, consider what is being said. Evaluate whether the study achieved its goal. If so, do the conclusions make sense and have practical significance? So sometimes the conclusion sure can make sense, but is it practical? Does it actually mean anything? Maybe, maybe not. So these are some questions you can ask yourself about the conclusion. And our last example, an experiment is conducted in which the weight losses of people who try a new fast diet supplement are compared to the weight losses of a control group of people who try to lose weight in other ways. After 10 weeks, the results show that the treatment group lost an average of a half pound more than the control group. Wait, they lost and then more? Oh, that's weird. That's okay. Okay. Assuming that there is no dangerous side effect, does this study suggest that the fast diet supplement is a good treatment for people wanting to lose weight? A half pound more? No, I don't know. That's not that much more, right? Just 1/2 of a pound? That doesn't sound very efficient to me or effective at all. I would say that's nice that they lost a half pound more, but in the grand scheme of things, that's not really that much. So I would say not statistically significant, no practical significance, no, nope. And then here's just a summary of those 8 guidelines again. So we talked about these 8 guidelines to follow when you're presented with a statistical study. Let's see them one more time. Get a big picture view of the study. Consider the source. Look for bias in the sample. Look for problems in defining or measuring the variables of interest. Beware of confounding variables. Consider the setting and wording in surveys. Check that results are presented fairly. Stand back and consider the conclusions. I hope you enjoyed these 8 guidelines and you can put them to good use as you read your newspapers and the statistics presented to you on TikTok and Facebook. Thank you for stopping by.